Hi guys, this is Arvind from MindMajix, and today I welcome you all to this amazing session on data structures interview questions. Okay, so guys, no matter like you're a fresher or an experienced candidate, so data structures and algorithms is one such topic around which you must have a good understanding so that you become a very good software developer or a software engineer. Okay, so this topic is very critical as far as interviews are concerned. Okay, so that's why we decided to come up with this video. And in this particular video, we have divided the questions into, two categories. The first category of questions is for freshers, and the second category of questions is for the experienced candidates. Okay, so this is the whole idea, or you can say the agenda for this video. Okay, and let me tell you in advance that if you talk about the data structures, so data structures and algorithms can be implemented in any programming languages like C, C++, Python, Java, JavaScript, and so on. Okay, so we've just covered the concepts in this video. Okay, so if you are like, you can implement them in any language that you know, as I told you earlier, C, C++, or whatever. So in this video, we are just going to discuss the concepts. Implementation is up to you, like in which language you want to implement them. Okay, so without any further delay, let's get started. And before moving ahead, I want you guys to subscribe to MindMajix YouTube channel and also hit the bell icon so that you never miss an update from us. So the first question over here is, what is data structure? So the data structure is nothing but an entity where the data is perfectly aligned and can be manipulated as per the requirement. When we deal with the data structure, it is not just about one table of data, but it is about different data sets and how well they are aligned with each other. Overall, it helps the data to be organized. Okay, so that is the whole idea behind data structure. The next question is, what are the basic operations that can be performed on various data structures? Okay, so guys, as you can see on the screen, these are the various operations that can be performed on data structures, such as insertion, deletion, searching, traversal, merging, sorting. Okay, so insertion is nothing but adding a new data element in the data structure. If you talk about deletion, so deletion process removes a data element from a data structure. Searching involves searching for a specified data element in the data structure, and traversal means processing all the data elements which are present in the data structure. Next, you have merging. So merging combines two similar data structures to form a new data structure of the same type. And last but not the least, sorting means arranging data elements of a data structure in a specified order, like ascending order or descending order. Okay. The next question is, what is a linked list? So a linked list is nothing but a sequence of nodes. So with this sequence, each node is connected to the following node. In this particular way, it forms a chain of data storage. The next question is, explain how do you reference all the elements in the one-dimensional array? So to reference all the elements in the one-dimensional array, we have to use an index loop. So with the help of this, it executes from 0 and to the size of the array, which is -1. Let's say, for example, if you have an element, or you can say if you have an array of 5 elements, so the counting will start from 0 and it will go up to 4. So which is basically 0 into n-1, where n is the size of the array. The next question is, list out all of the areas where data structures is applied. So the data structure is a very critical or crucial aspects while handling the data. And if you talk about the areas where data structures is applied, you can find their application in numerical analysis, operating systems, artificial intelligence, database management systems, statistical analysis, and so on. Now, guys, the next question is a very important question. So the question says, what is infix, prefix, and postfix in data structure? So the way to write an arithmetic expression is known as notation. And basically, there are three types of notations used in an arithmetic expression. So without changing the essence or output of the expression. So guys, as you can see on the screen, the notations are infix, prefix, and postfix. So if you talk about prefix, so in this, the operator is prefixed to operands. That is, it is ahead of operands. Okay, so guys, if you talk about x plus y, let's say there is an expression called x plus y. So here plus is the operator and x and y are the operands. So in prefix, the operator is placed ahead of the operands, which is x and y. Okay, as you can see here, plus x and y. So this is basically prefix. And if you talk about infix, so here the operator is placed in between the operands. So as you can see here, this is plus symbol, which is the operator, and these are the operands x plus x and y. So operator in between operands. So this is basically infix. And if you talk about postfix, so in this the operator is postfix to the operands. That is, it is placed after the operands. So as you can see here, x, y, and then you have the plus or the operator. So this is basically infix, prefix, and postfix. So similarly, you can see here, you have other expressions as well. So x plus y star z. Similarly, you have star plus xyz, and then you have x, y plus z star. Okay, so by giving such examples, you can explain what do you mean by infix, prefix, and postfix. Now, guys, the next question is explain the terminology LIFO. So LIFO is nothing but last in, first out. So this process describes how the data is accessed, stored, and then retrieved. So the latest data that is stored in the database can be extracted first. The next question is, what is a binary tree? So it is one type of data structure that has two nodes, that is left node and the right node. So in a programming language, binary trees are considered to be an extension to the linked list. The next question is, what do you mean by a stack? So the stack is considered as a data structure where the top layer element can be accessed. So the data is stored in the stack, and every time when the data is stored, it pushes the data downwards, which enables the users to access the latest data from the top layers. So in the previous question, we have seen what is LIFO. So basically, stack is one such data structure which follows this last in, first out. The next question is, what is multidimensional array? So multidimensional arrays use multiple indexes in order to store data in the database. In a few scenarios, data cannot be stored using a single dimension index, and in these scenarios, multidimensional arrays are very useful. The next question is, explain whether a linked list is considered as a linear or a non-linear data structure. So this is purely determined on the requirement basis. So a linked list can be considered as a linear data structure or a non-linear data structure. For example, if the linked list is used on storage, then the linked list is considered as a non-linear data structure. Whereas if the linked lists are used against the access strategies, then they are considered as a linear data structure. The next question is, explain how does dynamic memory allocation will help you in managing data. So a dynamic memory allocation will help you effectively manage your data by allocating structured blocks to have composite structures that can be flexible. That is, it can expand or contract based on the requirement. Also, they are capable of storing simple structured data types. So guys, basically dynamic memory allocation is one such feature which will help you effectively manage your memory, which you allocate for your data. The next question is a very important question. What do you mean by FIFO? So FIFO basically stands for first in, first out. So this process defines or depicts how the data is stored, inserted, and accessed in a queue. So within this process, the data that is inserted at the beginning of the queue will only be extracted or accessed first. The next question is, explain merge sort and how it is useful. So merge sort is nothing but a process where the data is divided and sorted to reach the end goal. So within this process, the adjacent elements are merged and sorted to create bigger elements. So these sorted elements are gathered again and made the even bigger list. So this process is continuous and repetitive until and unless they have nailed it down to a single sorted list. The next question is, list out all the advantages of a linked list. So the important aspect or advantage of a linked list is that it is a perfect data structure where the data can be modified very easily. Also, it doesn't matter how many elements are available on the linked list. The next question is, explain the main difference between push and pop operation. So the two main activities, that is pushing and popping, applies on the way how data is stored and retrieved in an entity. So if you check in detail, a push is nothing but a process where the data is added to the stack. On the contrary, a pop is an activity where the data is retrieved from the stack. So when we discuss data retrieval, it only considers the topmost available data. The next question is, how does a variable declaration activity will consume or affect the memory allocation? The amount of space or memory is occupied or allocated depending upon the data type of the variables that are declared. So let's explain this concept by taking an example. So if you declare a variable of an integer type, so it will take 32 bits of memory for its storage. Okay, so guys, 32 bits mean nothing but 4 bytes. So 1 byte is 8 bits. Okay, so in this particular way, you have different bytes for different data types such as float. Then you also have character. Okay, then you have long int and so on. So based on the data type of the variable, the memory space will be allocated. The next question is, define the advantages and disadvantages of heap and compare it to a stack. So guys, if you talk about the advantages of heap compared to a stack, so heap is more flexible when compared to a stack, and the memory space of the heap can be actually allocated and deallocated as per the requirement. On the contrary, if you talk about disadvantages of heap compared to a stack, the memory of the heap is slower when compared to the memory of the stack. The next question is, explain how new data can be inserted into the tree. So guys, there are basically two steps that you need to follow here to insert the data into the tree. So first, you need to check whether the data is unique or not. So what do you mean by unique? So you have to check whether the data that you're going to insert, whether it exists already in the tree or not. Okay, after that, you have to check if the tree is empty. So if the tree is empty, all you need to do is just insert a new item into the root. So if the key is smaller than the root's key, then insert the data into the root's left subtree, or otherwise insert the data into the right side of the root's subtree. So this is how you insert new data into the tree. The next question is, can you tell me minimum number of nodes that a binary tree can have? So a binary tree is allowed, or it can have minimum 0 number of nodes. Further, a binary tree can also have 1 or 2 nodes. The next question is, explain a little bit about the dynamic data structure. So the nature of the dynamic data structure is different compared to the standard data structures. The word dynamic data structure means that the data structure is flexible in nature. So what do you mean by flexible? So you can declare it and use it in the runtime. Okay, so it is not static, as in you do not have to, declare everything from the beginning. Okay, so you can use data structures like dynamic data structures on the go as and when it is needed. So it helps the users to manipulate the data without worrying too much about the data structure flexibility. The next question is, what is an array? So while referring to an array, the data is stored and utilized based on the index, and this number actually correlates to the element number in the data sequence. So it makes it flexible to access any data in any order. Within the programming language, an array is considered as a variable having certain number of indexed elements. So guys, whenever you asked such a question in the actual interview, like what is array, what is stack, what is linked list? So what you can do is, if you know any particular programming language, let's say, for example, if you know C programming language, so based on that language, you can simply write or declare an array with some elements. Okay, so that way, you give an impression on the interviewer that you are very well aware of the hands-on experience, or you can say you have hands-on experience with data structures. Okay, so you know how to create an array, how to add elements in the array. Okay, so you know what is multidimensional array, you know what is one-dimensional array, and so on. So now let's move to the next question. So tell me the minimum number of queues that are needed to implement a priority queue. So the minimum number of queues that are needed is 2, out of which one queue is intended for sorting priorities and the other queue is meant for the actual storage of data. The next question is, list out all of the different sorting algorithms that are available and state which sorting algorithm is considered as the fastest? So if you talk about the sorting algorithms, so here you have, as you can see on the screen, quick sort, bubble sort, balloon sort, radix sort, merge sort, and so on. So out of the above sorting options, none of the sorting algorithms can be tagged as the fastest algorithm. And that is because each of these algorithms is defined for a specific purpose. So based on the data structure and the data sets available, the sorting algorithms are used. The next important question is, what do you mean by a dequeue? So a dequeue is nothing but a double-ended queue. So within this structure, the elements can be inserted and deleted from both the ends. The next question is, explain the process of how selection sort works. So guys, in this particular question, like whenever you're asked such a question, so what you can do is you can write a small snippet of code to explain how selection sort works. So selection sort is a process where it picks up the smallest number from the entire data set list and places it at the beginning. So the same process is continued where the second position is already filled in. So the same process is continued all the way until the list is completed. So the selection sort is defined as a simple sort algorithm when compared to others. So guys, whenever you're asked such a question, one more thing that you must mention is the time complexity and the space complexity of those algorithms. So the next question over here is, what is a graph? So a graph is nothing but a type of data structure that has a set of ordered pairs. In turn, these pairs are again acknowledged as edges or arcs. So these are used to connect different nodes where the data can be accessed and stored based on the needs. The next question is it possible to implement a stack using a queue? So guys, this is a very tricky question, and this question is, based on a scenario. Like if you have experience of at least 2 to 3 years and you have actually implemented stacks and queue in your company or a project wherever you're working, so you'll be able to answer this question. So the answer to this question is yes, you can implement a stack using two queues. So any data structure to act like a stack should have the push method and pop method. So push basically is used to add the data on top, and pop is used to remove the top of the data. The next question is, how would you implement a queue using a stack? So in the previous question, we saw how to implement a stack using a queue. And now, how would you implement a queue using a stack? So using two stacks, you can implement a queue. So the purpose is to complete the queues and queue operation so that the initial entered element always ends up at the top of the stack. So first, to enqueue an item into the queue, migrate all the elements from the beginning of the stack to the second stack, and then push the item into the stack and send all of the elements to the back to the first stack. So to dequeue an element, an item from the queue, return top of item from the first stack. So this is how you implement a queue using a stack. The next question is, where is the LRU cache used in data structure? So in data structures, you use the least recently used or LRU cache to organize items in order of use. And this enables you to quickly find out which item hasn't been used for a long time. The next question is, which data structure is used to implement the LRU cache? So to implement the LRU cache, you should use two data structures, which are hash map and a doubly linked list or DLL. So a hash map helps with the lookup cache keys, whereas a DLL helps to maintain the eviction order. So guys, the next very important question of this session is, what is the difference between an array and a linked list? In this particular question, like comparison between array and linked list, so what we have done is we have drawn a table, and in those table, we have two columns, one for array and the second one is for linked list. Okay. So if you talk about array, so array is nothing but a sequence of elements of similar data type. Okay, so you can have an array of integers or you can have an array of characters, but you cannot have an array of integers and characters both. So if you talk about linked list, a linked list is a set of objects known as nodes where it internally consists of two portions, which is data and the address. The second point in array is array can be accessed irregularly using the array index. Okay, so as we have seen earlier, this size of the array is 0, like n, like the array starts from 0 and it ends to n-1, where n is the size of the array. If we talk about linked list, so linked list support random access and it only supports sequential access. If we talk about array, so array elements store in contiguous locations in memory. Whereas in linked list, new elements can be stored anywhere and a reference is created for the new element using pointers. Okay, so guys, this is a very important point as far as the difference between array and linked list is concerned. Now in arrays, memory allocation is done during compile time. Okay, whereas in linked list, memory allocation is done during runtime. Okay, so this is a static allocation in array and here it is dynamic allocation in case of linked list. The next point over here is array size must be defined at the time of declaration or initialization, whereas linked list size grows when new elements are inserted or deleted. Okay, so these were some of the critical differences between linked list and array. The next question is, what are the advantages of linked list over array? So guys, there are 4 points that you can mention in this particular question. So the first point is dynamic data structure. So linked list is dynamic data structure so that it can grow at runtime by deallocating and allocating memory. So there is no need to present the linked list initial size. The next point is insertion and deletion operations. So insertion and deletion operations are easier in linked list. So you need to have to update the address present in the next pointer of the node. Then you have the implementation. So data structures like queue, tree, stack are easily implemented using the linked list. And last but not the least, there is no memory wastage in linked list. So efficient memory utilization can be achieved in the linked list. The next question is, what are the applications of stack in a data structure? So guys, if you talk about the applications of stack in general, so stacks are used for expression evaluation, backtracking, function calling and returning, memory management, checking parentheses, matching in an expression. Okay, so let me give you one such example where stack can be used. Okay, so stack can be used in infix, prefix and postfix also. Okay, so if you have an expression and you want to find out the infix, prefix and postfix of it, so you can use stack. Okay, the next important question is, what are the different types of linked list? Okay, so guys, as you can see on the screen, these are the types of linked lists that are available. The first one, or the first diagram, as you can see, is it is that of a singly linked list. So this is the most common type and each node has the data and a pointer to the next node. Okay, so here, as you can see, you have the head, which is the beginning of the linked list. Then you have the data and you have the next. So next is basically the address of the next node of the linked list. So similarly, you have the data, which is the second node, and then you have the third node. And then you have the null, which is the end of the linked list. So head marks the beginning and null marks the end of the linked list. Similarly, you have the doubly linked list. So in this type, the pointer is added to the previous node, either in the forward or the backward direction. Okay, so guys, as you can see here in the doubly linked list, you have the head and null. Okay, so head and null is defined in the first location. Just because this is doubly linked list, it has the address of the next as well as previous data. Okay, so similarly, this is the first node, then you have the second node and the third node, and the end of this linked list is null. Okay, after this, you have the circular linked list in which the last element is linked to the first element. Okay, so this is the head is similar to the singly linked list. Similarly, you have nodes like data next, and data next, and the difference is the last element is linked to the first element. So in this way, it completes a circle, and that's why it is called a circular linked list. The next question is, what is the difference between storage structure and file structure? So the main difference between storage structure and file structure depends on the memory area that is accessed. So if you talk about storage structure, so it is a data structure representation in the computer memory. And if you talk about file structure, so it is a storage structure representation in the auxiliary memory. The next question is, what operations can be performed on a stack? So guys, as you can see on the screen, these are the operations that can be performed on a stack, such as push, pop, is empty, and peek or top. So if you talk about push, so push is basically used to add an item to the stack. So if the stack is full or complete, then it is an overflow condition. If you talk about pop, so it is used to remove an item from the stack. So if the stack is empty, then it is an underflow condition. Then you have the is empty. So if the stack is empty, it returns true, else it returns false. So basically is empty is used to check whether the stack is empty or not. Okay, then you have the peek or the top operation. So this returns the top of the stack. The next question is, name some of the important applications of data structures. So guys, data structures are vastly used in operating systems, artificial intelligence and machine learning, statistical analysis, database management systems, compiler design, and so on. The next question is, explain about linked list data structure. So a linked list is a series of data structures connected via links. So in simple words, it's a sequence of links that contains items, or you can say the data. So after array, the linked list is the second most used data structure. So the essential terms to understand the linked list are link, next, and linked list. So in a linked list, each link stores the data, which is nothing but the element. And in linked list, the next is nothing but the area where you have the address of the next element. So using next, these two elements are connected. Okay. And if you talk about linked list, so it contains the connection link to the first link called as first. Okay. So guys, whenever you're asked this question, explain linked list data structure, you can draw this diagram on a piece of paper. And you can also mention the operations which are supported by linked list, such as insertion, which is used to insert an element at the beginning or anywhere in the node. Then you have deletion, which deletes the element. Then you have the display, which displays the complete linked list. Then you have search, using which you can search an element in the linked list. Then you have delete. So in the delete operation, you can delete an element given a key. The next question is, are linked lists considered non-linear or linear data structures? So guys, it depends on where you plan to use the linked list. So you can consider a linked list for both linear as well as non-linear data structures. So when used for data storage, it is regarded as non-linear. And when used for access strategies, it is considered as a linear data structure. The next question is, what is a doubly linked list used for? So guys, this question is basically related to the application of doubly linked list. So first of all, in this particular question, you should mention how does a doubly linked list look like. So here you have the head, which is the starting of the DLL. Then you have the previous, which is the address of the previous node. Then you have the data, which is the element. And then you have the address of the next node in the next. Okay. So doubly linked list is one of the complex types of linked list where a node contains a pointer to the previous node and the next node in the sequence. So it consists of three parts: a node, a pointer to the next node, and a pointer to the previous node. So some of the real world applications where DLL are used are navigation systems and web browsers. Okay, so if you talk about web browsers, so whenever you click on the next web page in the browser, so you can go back to the previous web page. Okay, so this is one real world example of doubly linked list. The next question is, what is a queue in data structure? So a queue is a linear data structure that supports a specific order in which the operations are performed. So the order is of the FIFO methodology, which is first in, first out. So here the data items stored first will be accessed first. Unlike stack, the queue is open at both the ends, and one end is always used to insert the data and the other one is used to remove the data. Okay, and the operations that can be performed on queue are enqueue, which is to insert an item, dequeue to remove an item, is empty to check whether the queue is empty, is full to confirm whether the queue is full or not, and peek, which gets the element at the front of the queue without removing it. The next question is, list a few queue data structure applications. So as the name suggests, a queue is used whenever you need to manage a group of objects in the order FIFO. So few of the queue data structure applications are like serving the request on a single shared resource like the CPU, task, scheduling, printer, and so on. After this, you have handling interruptions in real-time systems. After this, you have buffer in applications like CD player and MP3 media players. In maintaining a playlist in media players, like adding or removing songs, so there also you can find the application of queue data structure. The next question is, what is the difference between a stack and a heap? So both stack and heap are used for memory needs. So the stack is primarily used to save the method execution order and local variables and always follow the LIFO order, whereas heap is used for dynamic allocation and deallocation of memory blocks. So it stores objects in Java, and memory allocated to the heap lives until one of the following events occur, such as memory free and program terminated. So the size of the heap memory is more when using recursion when compared to the stack, as it quickly fills up stack memory. The next question is, name a few graph data structure applications. So if you talk about the applications of graphs, so graphs are widely used in real time in social graphs, path optimization algorithms, recommendation engines, scientific computations, and so on. The next question is, what is an AVL tree? So if you talk about AVL, so AVL stands for Adelson, Velsky, and Landy. So this tree is basically a self-balancing binary search tree where the variation of the heights of the right and the left subtree of any node is not more than 1. Okay, so a tree is balanced if the balance factor of each node is between -1 to 1, or else the tree is unbalanced and needs to be balanced. And guys, for more understanding, what you can do is in this particular question, you can draw an example of an AVL tree. The next question is, how do you detect a loop in a linked list? So guys, there are a few methods to detect a loop in a linked list, such as using Floyd's cycle finding algorithm. Then you can use hashing, and you can use visiting nodes method to detect a loop in a linked list. The next question is, what is a jagged array? So jagged arrays are a particular type of arrays used for storing rows of data of varying lengths to improve the efficiency when working with multidimensional arrays. The next question is, what is the max heap in the data structure? So a max heap in the data structure is a complete binary tree where each internal node's value is greater than or equal to the node's children's values. The next question is, how to find the height of a node in the tree? So you can find the height of a binary tree using depth first search or the DFS algorithm, such as base case. So in the base case, if there is no node, you will return 0. Else, if there are 1 or 2 children, so you return the peak of the height of the left and the right subtrees plus 1 to account for the current node. Okay, so basically using DFS, you can find the height of a node in a particular tree. The next question is, list the types of trees. So guys, you have various types of trees such as general tree, binary tree, forest, expression tree, binary search tree, tournament tree. Okay, then you also have AVL tree, as we have discussed previously. So the next question is, which data structures do you use in DFS and BFS algorithms? So if you talk about depth first search or the DFS algorithm, so here you use the stack data structure, and in BFS or the breadth first search algorithm, you use the queue data structure. So guys, with this, we have come to the end of this session on data structures interview questions. I hope you guys have enjoyed this session and you have understood whatever we have covered here. So whenever you have your upcoming interview related to data structures, so what you can do is you can go through this video, and this video will serve as a revision to your knowledge. Okay, so you can revise your concepts or the knowledge that you already have related to data structures. So if you have any queries related to this session, then you can write them in the comment section, and my team is here to help you with all your doubts and queries. So guys, thank you so much for being with us, and all the very best for your upcoming interview.